Hello, 7th graders. Today we start our new chapter on probability. Now, this lesson is just going to be kind of an introduction. There's a lot of important vocab. First, we're going to investigate the idea of likelihood. So the likeliness of an event, which we'll later calculate as probability, is just the likeliness that it happens or that it occurs. So let's read number 1. You win a game if you correctly guess which color you will spin on the spinner shown. Which color would you choose? Well, our options are red or blue. And I don't know about you, but I would guess that it lands on blue because there is more blue than red. It is more likely that the spinner would land on blue than red. So we could actually spin this spinner 30 times and record our results. What would happen is the blue should show up more times than the red. Now, in class, we might actually make a spinner like this, but for the notes video, you're just going to have to pretend that we spun it and the data did support it. Number 4, this is where I am now. You spin one of the spinners below 30 times and record your results in the table. Which spinner do you think you might have used? Okay, so if these are our results, we got 14 blue and 16 red. It looks pretty close to half and half. So I'm going to say it's not this one and it's not this one. However, both of these spinners are 50% blue and 50% red. So I think either of these are likely to give us the outcomes of 14 spins on blue and 16 spins on red. All right, so here's that important vocab I was talking about. First, an experiment is an investigation or a procedure that has varying results. The sample space of an experiment is the set of all possible outcomes, all possible results. So that means outcomes are possible results. And then a collection of one or more outcomes is called an event. And the outcomes of a specific event, which is normally what a question might be asking you for, would be favorable outcomes. So for an example, an experiment might be rolling dice. The sample space would be all possible outcomes. So we got numbers 1 through 6. An outcome is what actually happens. So if I actually roll the dice and it lands on a 1, that's my outcome. Now, landing on a 1 could also be an event. However, an event might also be like landing on an even number. I might say even number or an odd number. If we were to calculate the probability that a dice would land on an even number, we would have to use the favorable outcomes in comparison to the sample space. So they give another example down here. If I had those 6 marbles in a bag, the sample space would be each of those 6 marbles. And then an event might be choosing a green marble. There are 2 green marbles out of 6 total. All right, let's look at example 1. You spin the spinner, find the sample space. So we could do this multiple ways. We could do colors or we could do numbers. So a sample space might be 1, 2, 3, 4, because there's 1 through 4. But it could also be red. I'm going to switch to my pen here. Red, green, blue, purple. Because those are the 4 colors. In how many ways can spinning a number less than 2 occur? Well, only one is less than 2. So there are 3 ones, or 3 numbers less than 2. And then not less than 2 would be 2, 3, and 4. So there are 3 there as well. So this one was just 1, this one was 2, 3, and 4. All right, so you randomly choose one of the tiles shown from a hat. Find the sample space. So the sample space is literally these letters. So we would write A, B, C, D, E. How many possible outcomes are there? 5. How many ways can choosing a vowel occur? Well, there's 1, 2, 3 vowels. All right, so in later notes, we're actually going to calculate probability, but today we're just going to look at probability as the likelihood that an event will occur. So probabilities are always between 0 and 1. That's also 0 and 100% because 1 is 100%. Probability can be expressed as a fraction, decimal, or percent. So you can see this little chart of how if it's impossible, it's 0 or 0%. If it is equally likely, it's 1/2, 0.5, or 50%. So those are all the same number. And then if something is absolutely going to happen, so rolling a 6-sided dice and landing on a number 1 through 6, that's 100% going to happen. So certain can be explained as 1 or 100%. All right, example 2. The chances of rain, thunderstorms, hail, and high winds today are shown. Describe the likelihood that there is rain today. Well, rain, it says, is 80%. 80% is pretty likely. Not certain, not equally likely, just pretty likely. Describe the likelihood that there are thunderstorms today. This is 50%. So we're going to say as likely as not. You could also say equally likely. Those mean the same thing. All right, describe which is more likely today, hail or high winds. Well, hail is only 15%, high winds is 20%. So while both are unlikely, winds are more likely. Okay, the probability you land a jump on a snowboard is 1/10. Describe the likelihood of the event. I think you need some snowboard practice. 1/10 is unlikely. Okay, last example. The data display shows data from a recent baseball season. An outfielder has to run 80 feet to catch a ball with a hang time of 6 seconds. Describe the likelihood that the outfielder catches the ball. Well, notice feet is on the x-axis and hang time is on the y-axis. So I'm going to find the point 80 feet 6 seconds. So 80 feet 6 seconds should be about right here. That's that light bluish area. I'm not exactly 100%, but I think it's somewhere in here. So the catch is likely. Not 100%. So not certain, not equally likely, just likely. So because the percent is close to but not equal to 100%, it is likely that the outfielder catches the ball. All right, I am going to have you do this one today. The data display shows more data from penalty kicks in a soccer league. Describe a location of a penalty kick that is likely to be successful. Well, notice the closer red it gets, the more likely it is successful. So anything out here is likely to be successful. Now, if this is the location of a kick at a goal, why might it be on the outside is more likely? You probably have a goalie here in the middle, and if you shoot it at the goalie, he's gonna block it. So this is some interesting data that makes sense, that says the closer to the outside of the net you get, the more likely it is to be successful. All right, please see Canvas for what your assignment is today. I believe there are also practice problems, and you will be submitting the entire notes PDF.